Hi students, good morning. Myself Dr. S. Ravindran, Assistant Professor in the Department of EEE, KPR Institute of Engineering and Technology. Today I am going to present a topic on different types of vehicles, that is electric vehicles based on sources of energy it is being using. So different types of vehicle, we have conventional vehicle, hybrid vehicle, plug-in hybrid, all electric vehicle and fuel cells. So as we know, conventional vehicles, the source of energy is IC engines and it consumes gasolines. So emission is more. In case of hybrid, majority is through IC engine, power through IC engine, and electric supports the propulsion or stopping criteria. So some other ancillary things, it is supported by electric motors. So here the fuel it saves is bit 10 to 15%. So the emission is reduced. Then plug-in hybrid, it has an IC engine and also electric motors to propel the vehicle. So it has a charging port to charge from the grids. And all electric, it is completely running through electric source. So electric motor supports the propulsion. Fuel cells, it has a gasoline IC engine to support and also electric motors. So here the sources of energy is derived from fuel cells. So we know that fuel cell output is an electrical energy. Right? Okay. Here we see about hybrid vehicle, and this degree of hybridization is based on the contribution by IC engine and electric motor. Okay, so for example, these hybrid vehicles will be propelled with two sources like a diesel engine and electric. So gasoline engine and electric, nuclear and electric. So here the vehicle is not only merely on four wheelers on the roads, even we go with some submarines, ships and other things. So we you know that we have an nuclear powered submarines, and it also driven through electric power too. So it is nuclear and hybrid. You don't get confused with the thing that nuclear and electric hybrid vehicle, where is there a vehicle with nuclear energy running on the roads. Okay, so okay, fuel cell and electric hybrids. So we know that this degree of hybridization you can see on this picture. So this is an engine, IC engine. So the contribution on conventional vehicle by IC engine is maximum and its conversion efficiency is low. With increase in electric motor contribution in its propulsion, and this contribution by IC engine is getting reduced. So efficiency of power conversion is also increased. So we have some examples for micro hybrid electric vehicle, medium, full hybrid, plug-in hybrid, and all the things. We have vehicles on the roads. So how to calculate hybridization ratios? Here I have given a numerical example. You can solve this and calculate what is a percentage of hybridization, right? We usually call it as hybridization ratios. So different types of vehicle based on the sources of energy. So according to degree of hybridization, we call that as a medium hybrid, full hybrid, or mild hybrid. Okay. So according to architecture, IC and motor interactions, we call that as series parallel, and complex hybrid electric vehicles. So according to the position of motors with reference to IC and transmission, so we have a P0, P1, P2, P3 and P4. These are based on the position of motors. We are calling that vehicles in named as P0 to P4, right? So according to number of motors, we can have one motor, two motor, or more than two motors in an electric vehicles. So we can categorize based on the number of motors in the vehicle too. So different types of vehicle. So sources of energy, based on source of energy we categorize that in mild hybrid. So it is ideal for stopping and regenerative braking. So it is not capable to propel the vehicles. So it is less cost and less fuel saving. Maybe from 5 to 10 percentage of fuel can be saved in braking and using of charging the batteries, and we can utilize for ancillary services. So this motor will be of maximum 48 volt motors will be used in these vehicles. Maruti Ciaz has this kind of mild hybrid vehicle. So it has a 10 kilowatt and 50 newton meter electric motor. Then comes a medium hybrid. So with the medium hybrid 2, it is ideal for stopping and regenerative braking. And here too, this electric motor cannot propel our vehicle. Okay, this somewhat costs more than mild hybrid. Fuel saving is more. It has maximum. This motor has an voltage rating up to 158 volt motor, so it saves fuel up to 20 percentage. And Honda Civic is one of the example of this kind. Okay, and full hybrid. So here completely it runs on electric motors. So it is ideal for stop and regenerative braking too, capable to propel the vehicle to this costs more and more fuel savings. So usually this voltage ranges from 220 to 800 volt motor. Okay, it saves fuel up to 30 to 50 percentage of the fuel consumption. uh, so Toyota Prius Grand Vitara of full hybrid or strong hybrid we can say. So these vehicles were available on the roads. So based on the architecture, I said it is based on the architecture series, parallel, complex or series parallel. So this is a series type of hybrid. So IC engine is coupled with alternator. The power, electric power is generated and it is fed to the converters. Converter can through the power to motor to drive the vehicle and also to batteries to charge. And again electric motor can run from the battery alone, even in case of IC engine is in off position. So here the electric vehicles speed is not depending on IC engine. So IC engine can operate at any speed. So IC engine can be run at its sweet spot, we call that as maximum efficiency point. Okay, so there is a flexibility in engine operation. Then parallel hybrid. So vehicle can be propelled with IC engine and also motor. Sometimes IC engine is supported through motor. So motor can increase the vehicle torque when IC engine could not deliver the required torque. Okay, so this is a parallel hybrid. So it combines IC and electric motors, so assist the engine to provide power. Okay, so this can improve fuel economy also. Then we have a series parallel hybrid. So here the vehicle can also run through IC engine and also through electric motor. Okay, and it can isolate from each others. So it can only drive through motor, or it can also drive through IC engine alone, or both of them can support the propulsion. Okay, so it needs a generator, larger battery packs, and more computing power to control dual systems, somewhat costlier than series and parallel hybrids. So based on different types of vehicles, motor positions. So I said as P0, P1, P2, P3, and P4, right? So P0, which is along with the engine, and it aids engine speed, movement, and everything. So the transmission is coupled only to IC engines. Electric motor supports the engine. So this kind of position of motor is we call it as P0. Okay, P1, the electric motor is placed in between IC engine and transmission. So the IC engine which rotates the transmission, also electric motor also supports this transmission. Okay, then this is a P1 type. P2 type has an gearing mechanism to isolate itself from IC, supporting IC, or it can continuously support IC engine for movement of these electric vehicles. So it can be placed in between transmission as an series coupling or as an parallel coupling. Okay, so in case of P3 and P4, it can be electric motor is placed near the differentials, and in P4 it is placed on the wheels. Okay, so it will be placed on the wheels. So next slide will show you somewhat clear picture of this. I represent the P4, sorry, it is on P5, which will be on the wheels, hub motor we usually call that as. So P0 with IC engines, P1 is between the transmission system and the engine on the shafts, and P2 is near the transmission. P3 and P4 are on the differentials, near the differentials, and P5 on the wheel hubs. So okay, thank you guys. We will meet with the next topic on the next video. Thank you.